So good morning to all of you, Nana. Good morning, students. So in the previous class, we were discussing about how to measure length. What are the different methods we will follow to measure length? Two methods we will follow to measure length, Nana. One is direct method, another one is indirect method. Direct method means, in the sense, we will use any one instrument like scale, tape, wire. Like that, we will use one instrument to measure the length. That is called as direct method. Whereas indirect method means, hello? I don't know. You should not join. What is your name? What is your name? Afzal. I told you, no, already I told you. Yeah. So indirect method means without using instrument. Means if, for example, if the distances to be measured is very large, then you can't measure what do you say, instruments, no, like meter scale, tape. We can't use if the distances are very large. Best example for that is sonar. We will use indirect method only. Sonar we will use to measure the distances. See, submarines will be there, no, under sea, underwater, in sea. That submarines location and speed we can find by using sonar. Sonar means sound navigation and ranging. Sonar. You might have studied this about this one in your previous classes in general science. General science, okay? And radar. Radar. Radio detection reading. Here we will use light rays. Here we will use light rays. Here we will use sound waves. Sound waves. To find the distance of object. Clear? Okay. So what are these in detail? No need. Already you might have known this about this one. Now let us directly enter into the important points. Okay. So indirect method, or best example, best indirect method is, that is parallax method. Parallax method. Very important, and this is they are asking for your board examination. And previous year they have asked this question for 5 marks also. This question they have asked for 5 marks also. Okay? Yeah. So listen carefully. Keep concentration, yeah. See, what is parallax? Parallax means nothing but, see, all of you, let us do one activity in here. Take your pen. I hope you have taken your pen. Clear? Keep this pen in front of you now, like this. Okay? Clear? Now, at the back of your pen, let us suppose you keep one wall. Varun is saying that board is not clear. No, it is clear, Anna. It may be your network problem. Anyhow, I will upload a video. You see there. Okay? So take the pen. Take the one reference point, like one board. This is the board. No, I am seeing the pen, not the board. Clear? So take pen, and you see one reference frame also there. Means one wall. Towards the wall you stand. Okay? To take the pen. Clear? Now you have to see the pen only. Just to see the pen. Now, while seeing, just close your one eye. Clear? This is my left eye. I am closing. So when I close my left eye, when I observe this pen, you observe only pen, not wall. Only pen you observe. Okay? So when you observe the pen, now the location of the pen on the wall is here. Clear? Okay. Now close another eye. Right eye I am closing now. So when you close the right eye, the position of this pen has changed now. Little bit. The position of the pen has changed. Is it happened for you also? Observe that. What I am saying, keep the pen in front of you. Not not only pen, it may be any one object, finger also it is. Okay, so we have kept this pen here. Now by closing one eye, you observe the pen location. Now close another eye and observe the pen location. Is there any shift in the position of the pen? Is there any shift in the position of the pen? Is there any shift in the position of the pen? Yes, good. They are saying repeatedly. Yes, good. So you have observed. That means the position of that pen has changed. That position with respect to what it has changed, with respect to your background, whatever you have considered. Here I have considered this laptop as my background. If you see here like this, for this pen, background is board. So this background we call it as reference frame. Clear? Got it, na? So that shift in the position of that object with respect to the background is called as parallax. Very important definition. Definition is very important, na? Definition is very important. So what I am saying? Parallax means shift in the position of the object with respect to background. Reference frame. Clear? So there will be a little shift in the position of the object with respect to the reference frame background. That shift is called as parallax. Is called as what we call it? Parallax. Clear? Got it, na? And the distances that we will measure by using this parallax is called as parallax method. Method we will use here to measure the distances. Okay, so what type of distances? Which distances we will measure by using this parallax method? See, for example, if you want to measure distance of the moon from the earth, you can't go to the moon with a tape. Means directly we can't measure. Yes or no? So what is the indirect method? That is parallax method we will use. Got it, pointer? If you want to measure the distance of another planet from here, what is the possible way you have? You have to take one tape. You should sit in a rocket and you should go along with the tape. How much distance it is that you should see. It is highly impossible. It is not at all impossible. It is not possible. Clear? So what is the another alternate method? Alternate method to measure that much width distances is parallax method. Clear? See now here what I am saying. So here parallax method means here this is the object that we are seeing. Okay? This is the object that we are seeing. Clear? Right? Yeah. So this object I am seeing with my left eye. Yeah. So with my left eye when I see the object position is here. Let us imagine. This I am seeing. If I see with this eye, the object position is somewhere. That is, I am showing you as A. Clear? If I close this eye, and if I see with this eye now your object location will be somewhere else. There will be change in the position. Clear? Yes. Now you draw a triangle like this. Now these two lanes will intersect one angle here. This angle is called as parallactic angle. What we call it? Parallactic angle or parallax angle. Parallactic angle or parallax angle. And the distance between these two positions. We call it as basis. What we call it? Basis. And we will indicate with letter B. We will indicate with letter B. Got it? Clear? So what is parallactic angle? What is basis? You must know. Basis is the distance between the two shifts in the position of the object. One time we are seeing here, another time we are seeing here. Between these two position of the object, the distance is called as basis. Clear? Got it, Nana? Yeah. So now, let us use this method to find distance of a planet or moon from the earth. Okay, na? Clear? This is an important question. What is parallax method? And explain parallax method to find the distance of a moon or planet. They will ask you. Okay? So how we will use this method? Okay? So I am wrapping this one. Shift in the position of the object with respect to a fixed reference point or background is called as parallax, and the method is called as parallax method. Okay? So many times repeat it already. Okay, good. Now let us imagine that. Yeah. So we want to measure. This is the one object here. Let us imagine this is one star. Let us imagine this is a star or a planet. Clear? Okay. Now, let us imagine this is the Earth. This is what Earth. This is Earth. Clear? Okay. Now, what we have to do? This star we should observe from two different places. This is at one place where I am standing, and this point is I am calling it as A. Clear? From here I am observing that. Clear? Okay. Now let us draw a line here. This you call it as O, object, star. Okay. Now somewhere else you go from point B. Again you observe that star. How? Directly we can't see. We should use a telescope. Okay? And you draw one more line. The angle between these two lines. This angle is called as parallactic angle. Okay? And this distance we call it as basis. Basis. We call this distance as basis. Okay. Now here one important point is, see, the distance of this planet from the earth or the moon from the earth, it will be very large. Let us imagine this distance is capital D. Distance of that object or planet from the earth is capital D. It will be very large in comparison to B. Yes or no? Here, that means capital D is very large than B. Yes or no? Yes, definitely. To reference point on the surface of the earth. A and D, this will be very small in terms of meters or kilometers. Whereas this distance, thousands of kilometers. From moon, sun to moon only, thousands of kilometers is there. If you take star, means still more. Means capital D is very large comparison to B. Clear? Yes. Now you take D, that's why you take D upon D. Will become 1, no? D what you take? That means B upon D is very less than 1. Is very less than 1. Did you understand this point? Clear? Under this type of conditions, this angle, whatever the angle, we have taken, this will be very small. Clear? Now, when the angle is very small, now you can consider this basis you can consider it as like a arc. Clear? Now, it will become like this. This is the object and this is your basis. Clear? Why I am taking like this? Why I am taking? Because of this condition. B by D is less than 1. Why I am saying is distance capital D is however is very large. Thousands of kilometers it will be. Distance from the earth to moon or sun you take. Very large, no. 1.496 into 10 to the power of 14 meters it is. Very large. So, but small b, basis will be very small. Due to that, theta will be small. Okay, na? Clear? Let us imagine why this, sir. Okay, if you are not understanding. Okay, remove this. You can just say if theta is small. Theta is small. If it has happened, theta is very small. See, however, it is small because when the star is very large, far away from this earth, the angle equivalent substance will be small. So for the small angles, this will be this basis can be considered as an arc, and this distance can be considered as capital D. Now, in previous class, I told you that whenever you have this arc of length L, then length L, half arc of length L can be written as arc theta. Yes or no? Yes. No. What is L here? D. D can be written as R. What is R? Capital D into T. You want capital D, no? Yes. So capital D is equal to theta by D. Finish. We have got the answer. We want capital D. We know B. We can measure this B. We can measure this B. Basis we can measure because it will be nearby distance. Nearby distance. We can measure. Only the thing is we should measure theta. How to measure theta? We should observe from point A and we should observe from point B also. Then you will get angle between these two rays is theta. Once you measure this theta, then divide this theta with this basis, distance between these two observation points. Then you get capital D. That is distance of that far away objects, that is star, to the earth. Okay, this method is very simplest method, and we will use this method to measure very large distances. Clear? I hope you understand this. Yes, L is equal to R theta. L is equal to R theta. For an arc, today this is an arc of length L and this radius R. This will be theta. Then it can be written as L is equal to R theta. Yes or no? Yes, we can write. This is similar to this one. Here radius is capital D, length of the arc is B, and theta is theta. Same as this, both are same. This one and this one is same. Correct? No. Still doubts, sir? Okay, na? Got it? So, yeah, good. Now what I am saying, what is parallax method? And explain how we will use this method to find the distance of far objects like a moon or stars or other planets. Parallax is nothing but shift in the position of the object with respect to background. It's called as parallax. Parallax is shift in the position of the object with respect to background. Okay. So again, one more time they are asking students. This is the pen. Observe this pen with two eyes. One time with one eye, another time with another eye. This pen location is changing. That the shift is called as parallax, and the angle it is making there is called as parallactic angle. Okay, na? Yeah. Now, parallactic angle we call it as. Okay. Now, this is the star. From A and B points we are observing. This will be the bias, basis, and this is theta. It is similar to this. Can be written as B is equal to D, capital D into theta. We want capital D. This distance of this star and planet from this earth. So capital D will be given as theta by D. Clear? Okay. Now here theta, this theta is not in degrees, it is in radians. I told you, no, conversion between degrees to radians I told you already. Pi radian is equal to pi radian is equal to 180 degrees. This is the conversion. The theta, whatever I am writing here, this is not in angle, it is radian. We should write it in radians only. Okay? Here. Okay. Now, some students they are asking, sir, give me one problem on this. They are asking. Problem I will give you, no, it will take a time, unnecessarily time waste for us, because no one will ask you problem on this. No one will ask you problem on this. Okay? So not required. It will be calculation. Simply I have to calculate. You will ask me division, addition, these all things. Time waste process. So no need. You can solve directly. What I am saying, D is equal to theta by b. Okay, I will give you. Okay, this is the observation point. This is the bias. Let us measure this bias is equal to 2 meters. How much? 2 meters. Okay, and angle here giving is let us take 1 degree. Then what is capital D? Fine. On this topic, no. On this topic, they won't ask. In JEE, on this topic, they won't ask. This is important for board exam just for board exam, it is important. Okay. This is important only for board exam. So keep here. Theta is 1 degree. 1 degree. We have to write in radians. You know that pi radians is equal to 180 degrees. Then 1 degree is equal to pi by 180 radians. So you should write pi upon 180 by 2. Then you calculate. Pi means 3.14 upon 180 into 2. You calculate, you get the answer. Simple. Okay, clear? Okay. Now, see, for measuring these distances, we have different units. What are the different units? Let us discuss now. Okay? See, first one is angstroms. First one is angstrom. Angstrom. Yes, while doing calculation, angle must be taken as in radians only. If you remember that point. Okay? 1 angstrom is equal to 10 to the power of minus 10 meters. What is this one? What we have to call this? Angstrom. Angstrom. Okay? Distances unit, different practical units we will use. For distances are angstrom, 10 to the power of minus 10 meters. Okay? Next, Fermi meter. Fermi. 1 Fermi. 1 Fermi means 10 to the power of minus 15 meters. You must remember this. 1 Fermi meter or Fermi is nothing but 10 to the power of minus 15 meters. You must remember this. Clear? Next, AU. AU in the sense astronomical unit. Astronomical unit is, it is the unit for the measurement of length, and its value is 1.496 into 10 to the power of 14 meters. It is the distance from sun to earth. Astronomical unit. Astronomical unit. Astronomical unit. What is this? It is distance from sun to earth. You should remember this value. 1.496 into 10 to the power of 15 meters. Okay? It is very important value. You must remember. You must remember this value. What it is? Clear? Okay, Rana? Sorry, here 10 to the power of 11 meters. astronomical unit is 1.496 into 10 to the power of 11 meters. 10 to the power of 11 meters. Okay. What is this? It is the distance from sun to earth. Distance between sun and earth. This we call it as astronomical unit. You must remember this. Okay. And next very important one is light year. Light year. Light year is nothing but the distance traveled by light in 1 year. Light is there, no. It will travel with the speed 3 into 10 to the power of 8 per second. 8 meter per second means in 1 second 3 into 10 to the power of 8 meters it will travel. Now in 1 year how much distance it will travel? That total distance is called as light year. Okay, light year is very important. One light year value is 9.46 into value is questions I am making here. 9.46 into 10 to the power of 15 meters. Very important value. You must remember this. One light year value how much? 9.46 into 10 to the power of 15 meters. What is light year? Light year is the distance traveled by light that we are getting from the sun. It will travel some distance. The distance traveled by light in 1 year. Total in 1 year, how much distance it will travel? That distance we call it as 1 light year. Okay? And repeatedly they are asking a question on this. That is, light year is unit for. Light year is unit for what? Unit for what? 4 options they will give you. Time. First option they will give you time. First option only they will give you time. Second option length. Third option mass. Fourth option none of the above. What will be your answer? Light year is don't misunderstand that light year is not the unit of time. So many students they will think for time only. Light year is unit of length. Clear? Very important point. You must remember. Light year is the unit of length. One more question also they have asked for board exams. Before year, 1 mark question they have asked. Light year is unit for which physical quantity? Length. And what is the value of light year also they have asked. What is the value? 9.46 into 10 to the power of 15 meters. They have asked what is light year also. Light year is the distance traveled by light in 1 year. Okay? Yeah. Next, another unit is there. That another unit is parsec. Parsec. What is that one? Parsec. Parsec, it is the distance at which distance of astronomical objects. If you want to find, we will use this parsec. 1 parsec value is equal to 3.08 into 10 to the power of 16 meters. This is also important to remember this. One is astronomical unit, second one is light year, third one is parsec. You must remember these three. These three you must remember. Clear? Okay. And one more question also they are asking. There is range of length. Range of length. Very important. Everyone should remember this. This is 1 mark question for your board exams. Okay, what is range of length? Range of length in the sense it is nothing but the minimum value or maximum value or. Okay, if you give the minimum smallest value of length and the biggest value of length, and this we call it as range of length. Okay, smallest value of length is 10 to the power of minus 14 meters, and it is equal to radius of the nucleus. Nucleus will be there, no? Nucleus radius value means any length if you want to measure, you can measure up to this much smallest value. This is the minimum value, and the maximum value is 10 to the power of 26 meters. 10 to the power of 26 meters. 10 to the power of 26 is the radius of galaxy, you can say. Okay, the biggest length is 10 to the power of 26 meters. Okay, if anybody asks you what is the range of length, range means you should say minimum value what, maximum value what. Minimum value of length, smallest measurement of length is 10 to the power of minus 14 meters, and the maximum value is 10 to the power of 26 meters. So range is lies between 10 to the power of minus 14 meters to 10 to the power of 26 meters. Very important point, you must remember. Okay, so this is all about length. What is length, how we will measure, and what are the instruments we will use, and what are the different units, and what is the range of length. Clear? Okay. Next, another point is second fundamental point is mass. What is mass? Mass means what? Mass is nothing but it is amount of substance, amount of matter present in a substance. Mass is what? Amount of matter present in a substance. This we call it as mass. Okay, good. See, mass is of two types now. Mass is of two types. One is inertial mass. Inertial mass. Another one is gravitational mass. Gravitational mass. Inertial mass means what? Inertial mass means, see here, let us imagine here you are having one object. Here you are having one object. Clear? Yeah, you can write mass as a basic property of matter. Yes, you can write them, no problem. Okay? So what I am saying, inertial mass means what? Inertial mass means let us consider one object. Okay? Now on this object, let us apply a force here. Let us apply a force F on this object. Clear? Now what will happen? This will move. This object will move. Yes, definitely. It will move with some acceleration. Yes or no? Yes, definitely it will move with some acceleration. Now according to Newton's second law, F is equal to ma. Yes or no? Yes sir. Then M is equal to what? F by A. This mass is called as inertial mass. Clear? Got it? And the gravitational mass is the actual mass what we will measure. This gravitational mass we will measure by using physical balance. Physical balance. Gravitational mass in a sense, mass of an object which is affected by the acceleration due to gravity. Clear? In terms of definition, nothing but the mass of an object where it is in translatory motion. Definitions are not required. Whenever it is required, I will write because it is important. When it is not required, I won't write. Clear? Inertial mass means when object is in translatory motion, means in motion. Then mass of the object due to this translatory motion is called as inertial mass. Mass of the object due to effect of acceleration due to gravity is called as inertial mass. And these two are found to be equal. So no need to discuss in detail about this. These two are same only. Clear? Sometimes somewhere else, if you are reading reference books, you may see these two, inertial mass, gravitational mass. So that time you will ask me, sir, what is this? That's why I am explaining now only. Here, these two, inertial mass and gravitational mass, by doing experiments, scientists they have calculated that these two values are almost same. So no need, there is no difference between inertial mass and gravitational mass. Just mass only you consider. What is it, Nana? Here? Okay. Now, So how we will measure the mass? Mass we will measure by using physical balance. Okay? Yeah. Physical balance. Physical balance means what? This is the physical balance. Physical balance what does? Physical balance. Class. This is physical balance. Principle.